So welcome everybody to this H3D Foundation webinar for today. We're honored to have Dr. Sauvik Samanta join us. He's been at H3D for some years now, and a large focus of his work, apart from being a scientist, has also been improving the safety procedures and operations of H3D. So we're thrilled to have you. I'm going to read your bio just to kick us off. Dr. Sauvik Samanta earned his Ph.D. in Synthetic Organic Chemistry from the Indian Institute of Technology, Kanpur, in 2015. He further specialized in asymmetric organic synthesis through 2 prestigious postdoctoral fellowships at the University of Warsaw, Poland, and the University of Cape Town, South Africa. Dr. Samanta joined the Holistic Drug Discovery and Development Center, H3D, as a Medicinal Chemistry Postdoctoral Fellow in mid-2018, and was appointed as a Medicinal Chemistry Investigator in early 2022. His research is driven by a strong commitment to addressing infectious and neglected diseases, with a particular focus on malaria. In addition to his scientific contributions, Dr. Samanta has served as an occupational health and safety specialist at H3D for over 4 years, playing a key role in maintaining the safety and efficiency of advanced chemistry laboratories. He is equally dedicated to promoting physical and mental well-being, believing that holistic health is fundamental to sustain scientific excellence and innovation. Dr. Samanta thrives at the intersection of research, laboratory safety, and wellness advocacy. We're so thrilled to have you, Sauvik. Thank you so much for giving us your time and expertise. To everyone who's joined the meeting, please write your questions down or pop them in the chat, and we'll have Q&A at the end, as always. Over to you, Sauvik. Thank you.
Perfect. Thank you very much, Nicola, for your kind introduction. And I would like to thank H3D Foundation as well for giving me this opportunity to share my experience, and particularly choosing this topic like health and safety in chemistry laboratory, which is quite, means when people are driving in the science, sometimes health and safety is getting at the backside. So it is quite important to sometimes discuss about this topic as well. So as Nicola mentioned, I'd just like to highlight some point, like I have been working as a health and safety representative from the chemistry lab of H3D, because H3D is an integrated drug discovery center, having chemistry labs, biology, pharmacology labs, and other different labs as well. So I haven't have expertise in all the labs in terms of health and safety. I'm only responsible for chemistry health and safety laboratory, chemistry laboratories health and safety. So yeah, so now let's focus on the advanced chemistry health and safety. Why advanced? Because we are here not going to talk about the undergraduate laboratories health and safety. We will more focused in advanced chemistry laboratories, where people are more experienced chemists, and where we use more advanced technologies, advanced instruments, and different types of chemicals. So I'd eventually look into those areas. And rightfully, what Nicola mentioned, that I'm quite privileged, and I feel myself fortunate that I have quite significant experience from different advanced chemistry laboratories, leading institutes, at least from 3 universities. I would rather say 3 continents. So I have seen different kinds of work culture across the continents. And to my experience, I would like to say, like, the chemist, when they get more advanced in terms of experience, they are trying to, they become more reluctant towards the chemistry health and safety aspects, which is my own observation. I'm not talking about advanced laboratory in the industries, because in industry you have to follow certain procedures, you have to follow certain safety standard, but I'm more talking about the advanced chemistry laboratories in the academic area. So as you have seen these questions at the beginning, how serious we are about our health and safety standard in our day-to-day life. So I would like to give a simple example here. So as all of you know, like, car safety seat is quite important while you are in the road with your kids. And statistically, it has been shown that car seats has been reduced the risk of death of the children quite significantly. And I believe as a parent, everybody is quite has a highest priority of about about the safety of their children. But what in reality? In reality, particularly in this country, we have seen almost more than 80% of the children who are traveling in the car are traveling without any child restraints. Forget about the car seat. They are not even properly buckled up. Sometimes they are on the lap of the adults. Sometimes I have also seen multiple children sitting on the front passenger seat, which is extremely dangerous and which leads to, unfortunately, the passenger deaths in children is causing fourth leading cause of unnatural death in this country, unfortunately. So interestingly enough, with parents, like almost 80% of the parents are compromising their child safety on the road. And not only that, like drunk and drive, sitting in the back seat without buckling up, or crossing the road without pedestrian crossing. Everything is basically compromisation of health and safety on the road. And it is happening all over the world every moment. So yeah, just think about it. But yeah, this is not our topic, like road safety is not our topic. So our topic is health and safety in advanced laboratory. So I'd like to mention a couple of stories, true incident, which I experienced quite closely. The first experience is it happened when I was a PhD student, and it happened at the same institute, one of my neighboring lab. She was a third year PhD student. She was working alone at 6 a.m. in the morning. And interestingly, she was not wearing any lab coat. So I illustrated this picture using ChatGPT. Even ChatGPT knows that when you are in the chemistry lab, you should have a lab coat. But unfortunately, she was not wearing anything, and her dress was made of synthetic materials, which can catch fire easily. What procedure she was doing is she was basically drying THF under refluxive condition in presence of sodium. Those people who are not aware of that, there are several reactions which you need where you need freshly distilled THF. And the procedure was that she was following is there was a big heating mantle and a big flask of THF which was refluxing under sodium, and there is a small bulb which was collecting the freshly distilled THF, and she was taking out the THF using the syringe. Probably she was doing some big scale reactions, and at some point she realized that the amount of THF collecting in the flask was not in the bulb was not good enough. So she was trying to add some more THF in the round bottom flask. She didn't wait for cooling the flask. She tried to add it, like remove the condenser, tried to add it under the heating condition, and eventually the THF bumped on her in presence of sodium. She immediately got fire. And she was alone in the lab. Nobody was there to help. So she was running in the corridor. Luckily enough, there was another girl next door. She was able to help her to put down the fire. But by the time she was more than 40% burned, she was in the hospital for more than a month, and it took almost a year or so to come back to the lab again and complete her PhD, which is quite a, you can imagine the mental trauma as well. And the second story, it didn't happen to our, it did happen to another leading institute in India. I know this person because he was one class senior to me when I was doing my undergraduates. And this lab was not a hardcore organic chemistry lab or a hardcore wet lab. It was a solid state chemistry lab. And it was one of the best lab in India. The reason I'm telling it, his PhD student is a living legend in India. He got his the highest civilian award in India, which is called Bharat Ratna. And he has been nominated for Nobel Prize several times. Hasn't cracked it yet, but you never know tomorrow. But yeah, back to the incident. He was trying to lift a 2.5 liter aniline from a shelf overhead height. And eventually the bottle dropped on the bench and broken. And the aniline was soaked, fall on him, and it soaked on his jeans. Interestingly, he didn't care about that. He just ignored it. And what happened next? He started vomiting after 3-4 hours. He started feeling difficulties in breathing. He was taken to a hospital, and he spent few days in ICU. Eventually, he was survived. But if we look what happened, so aniline can easily, like now I'm coming to some chemistry, very simple chemistry equation. So aniline can easily soaked by your skin and easily can go to your bloodstream and eventually to your liver. And in liver, there are different types of CYP enzymes which can oxidize aniline to phenyl hydroxylamine. And this phenyl hydroxylamine can eventually give some reactive oxygen species like hydrogen peroxide. And this ROS has the capacity to rupture the membrane of red blood cell, which can cause the hemolysis. Not only that, this ROS has the ability to oxidize the hemoglobin to methemoglobin, which that means like less hemoglobin is available to carry the oxygen and tissue becomes oxygen deficient. And the result is hypoxia. And if you don't get a proper treatment at right time, it can kill a person. So from these two events, what we have seen, like what was wrong? There are so many things was wrong. For first incident, this person was, the girl was working alone in the lab. That is the first no. Like you can't be alone in a chemistry lab or any lab at any point of time. She was handling some sensitive reaction procedure alone, like lab procedure. So while you are doing this kind of lab procedure where the risk is involved, there should be some helping hand around you. She didn't follow the proper procedure. Like when you need to add more THF, you need to first cool down the big flask before adding the THF. Her clothes were not proper for working in the lab. And most importantly, she didn't wear any lab coat. Probably a lab coat could save her significantly. In the second case, the person was storing large material or heavy material over eye level, which is not ideal. Even if you are storing something that high, you must need to use some steps, which was not used here. And once you have a chemical spillage, you must remove your clothes immediately and wash yourself. And this procedure was not followed here. And again, there was no lab coat, which could again save him quite a bit. So when you are in a lab, you can't be a mad scientist like Norman Osborn from Marvel Comics, who turned into Green Goblin for not following the lab procedure properly. So once you are in a lab, there are a few rules you must need to follow. There are some simple rules. I think everybody is aware of that, like no food or drink allowed in the lab. You should wear personal protective equipment all the time. Then you should be aware of the emergency procedures. No cell phone call is allowed from the lab in the lab. And nowadays there is another problem is scrolling down through social media. That is also not permitted in the lab. And then at any point of time, you cannot work alone in the lab. There should be at least one person at your calling distance. And you must report any incident happen in the lab. I'll come back to this topic a bit later. So PPE, that is a basic thing before you go to in the lab. So the basic, the typical PPE is a safety glass, gloves, lab coat, long pant, and closed shoes. At H3D, we did a smart job choosing PPE, choosing lab coat. We have an elastic band at the end of the lab coat. So when you stretch your arm, there is no skin exposed. So this is a small implication and it has a big impact. And also there is a tendency like in summer, people use shorts or 3/4, but it is not ideal because your skin is exposed. For the same reason, toed jeans are also not ideal in the lab. If you are wearing a long skirt, it shouldn't be that fluffy that it can knock down things. Your shoes be always closed. Heels are not ideal in the lab. We don't recommend people to wear contact lenses in the lab because if something falls on your eyes, particularly the chemicals, if you have a contact lens, it can damage your even worse. And if you have loose ears, it must be tied properly. For choosing safety glasses, you need for normal safety glass, you need to have proper covering from all the sides, particularly from the side areas. And if you are wearing a spec like me, there should be a over spec safety glass. But sometimes when you are using two glasses, there is a slight power difference, and you can have kind of headache if you are working for a long time, and which can affect your productivity. So at H3D, we use prescription safety glasses, which is a bit expensive option, but in the long run, it can give you much more productivity. And there are some special occasion PPE as well, which we sometimes need to follow. For example, dust mask. If you are handling some fine particles like silica or lithium aluminum hydroxide, lithium aluminum hydride, you must wear dust mask. Because if you are inhaling silica for over the period of time, you can end up with silicosis. Lithium aluminum hydride is even dangerous. It has a ability to puncture your lungs. So dust mask can save you. We generally use half respirator when we are working in solvent storage, using large amount of solvent decanning or using liquid waste. Full respirator is not very often used, but sometimes if you are in a hazardous fume condition, this is the time you should use a full respirator. We encourage people to use face shield when there is a chance of spillage, or you can foresee kind of a spillage. I can give you an example. If you are handling a large amount of POCl3, phosphorus oxychloride, and if you have a doubt like you haven't properly quenched it, and if you are going to throw it in a liquid waste, particularly inorganic waste, it can bump back to you. So if you have a face shield, it can protect you from that spillage. And we all know about the use of surgical masks thanks to COVID-19. So if you are feeling unsafe, if you are feeling like if you are suffering from cold and flu, you don't want to contaminate your co-workers. So surgical mask is something that can protect the co-workers from you if you are feeling sick. Gloves is one very important part of PPE because it basically it is basically the barrier between your skin and the chemicals. So I must say that there is no perfect gloves for against every chemicals. So after doing some research of gloves materials, we have decided to use nitrile gloves against most of the chemicals. But you must remember that this is only spill proof. If there is a spillage, you must remove the gloves. Sometimes you may use double gloves to give you more protection. But these nitrile gloves cannot give you any protection against acetone. So if you are going to use going to wash your glassware with acetone, you must use latex gloves. But also need to remember that the breakthrough time of latex against acetone is only 10 minutes. So after 10 minutes, you should change your gloves. There are people who may have allergy to latex material, so those can use butyl gloves. And also, if you are handling a large amount of acetone for longer period of time, so butyl gloves would be your choice. Against DCM or dichloromethane, there is no gloves give you any protection except silver silk gloves, which is an expensive option, and we only use it at H3D. We only use it for cleaning up a large DCM spill. Then we also have green nitrile gloves, which is used for hazardous spill cleanup. So you know about your PPE, and before going to the lab, you must know the emergency exit first. So if there is an incident or your extraction is down or there is a fire alarm, you must evacuate the lab immediately. Then you should know where the safety shower and IOS is stationed. At H3D, we keep up clean clothes and clean lab coat in a closed bucket, so that if someone used this safety shower or IOS station and wet, then the person can clean himself and take the fresh lab coat. And then obviously you need to know the first aid station or a small cut or something like that. And you need to know the location of the fire extinguisher and a basic knowledge of use of fire extinguisher. Fire blanket is one important thing. So if somebody is on fire, if you put the fire blanket on the person, the fire should put down immediately. Sand is something is very important. I will discuss this more in the next slide. And we also have fireball. So if there is a big fire in your lab, for example, your fume hood is burning, then it is something like you can throw this fireball to the fume hood and there would be a small explosion and the fire will be put down immediately. So yeah, chemistry lab, there could be different types of fire. So you need to understand what kind of extinguisher we should use for different kinds of fire. For ordinary fire from wood, paper or clothes, you may use water, but it is not ideal to use water in the chemistry lab because there are different types of chemicals around. So powder extinguisher should be the weapon for you. For any flammable liquids, you can use either powder extinguisher or carbon dioxide extinguisher. For any fire from electrical equipment, we prefer carbon dioxide extinguisher over powder extinguisher because powder extinguisher can damage your expensive equipment or instrument. And if there is a metal fire, for example, fire from sodium or butyl lithium, you must use sand, nothing else. So if you are using that kind of material or chemical, you should keep the sand bucket next to you. So if there is a small fire, you can put down the fire immediately. Otherwise, if it turns big, it would be very difficult to put down the fire using limited amount of sand. So you know the emergency procedures and now you know the fire extinguisher as well. Now you are welcome to go to the place where the magic happens. That means the lab. The lab extraction is very important for the fresh air. If the lab extraction is down, then you shouldn't be in the lab. And another thing is the most important thing probably is the fume hood. So when you are not in the fume hood, not working on the fume hood, the sachet of the fume hood should be always down. And when you are working, you can open it half, or there is always a mark of on every fume hood, like until that level you can open your fume hood. Otherwise, it should be always closed, even you are working back, facing back. And the backside of the fume hood, there shouldn't be any obstruction with a big chemical bottle or something like that for the airflow. Otherwise, the fumes can come out. And obviously, your workplace should be clean and tidy, and there shouldn't be any obstruction on the floor. Yes, so once you are in the lab, you are surrounded by all those hazardous chemicals all around you. So at Ph.D, we try to differentiate the hazardous chemicals in different categories. There are main 8 categories. There could be some subcategories as well. So I'm not going to give you all the details of different kinds of chemicals, but I would like to highlight these teratogenic agents, which is the agents which can have an effect on unborn babies. So there are several common chemicals, including common solvents. Those are known to be teratogenic agents. For example, DMF of dimethyl-formamide. So if somebody is pregnant, it is employer duty to ensure that that pregnant person is not working with any teratogenic agent. And also you need to understand read or at least get to know the safety data sheet of every compound or every chemicals you are working with. Safety data sheet or SDS is well available from any supplier's website. Mark is very good at it. And from there, you need to understand or you need to know the hazard symbols, hazard statements. Hazard statements come with these H numbers. Any number beyond 300 is generally those compounds, those hazards are related to human bodies. Anything below 300 has an effect on environment. We should also be aware of that effect because we are responsible scientists. We have responsibility towards the environment as well. And with every hazard statement, there is a precautionary statement comes with this P number. And these statements give you the initial, so if something goes wrong with this chemical, so what you should do immediately, and you should get the information from this precautionary statement. So you need to know and need to be aware of these statements as well. So you do reactions, you use chemicals, you create waste. So waste management is very important in any chemistry lab. So and this is a waste management chart we use in our chemistry department as well as in H3D. So we separate our liquid waste in terms of halogenated waste, non-halogenated waste, and inorganic or aqueous waste. We separate our solid waste as well for silica and solid salt, silite waste. For example, we use this red RUC for contaminated gloves or papers. This green bucket is for broken glasses, or this yellow bucket, and this small yellow box is for sharp objects, for example, needles or blade, something like that. And all different kinds of kinds and types of waste has been collected by different companies and disposed accordingly. Then standard operating procedures, or SOP, that is very important, and one should have written SOPs in every chemistry lab. At H3D, we have written SOPs for all our instruments, LCMS, automated purification system, etc. We have written SOPs for different quenching methods, for pyrophoric materials, for water reactive materials, toxic materials. We have SOPs for waste management, for example, palladium carbonate waste, SOPs for different special techniques, uses of cannula, filling balloons with hydrogen gas or carbon monoxide gas, etc. So written SOPs should be available all the time to any employee, and it is also important to give proper training to the employee whenever it is needed. Then you follow all the procedures, you follow all the measurements, still any incident can happen. And this is quite normal. And it doesn't prove you are a good scientist or bad scientist. Incident can be divided in basically two categories. If there is a damage or loss is involved, that is called accident. If there is no damage involved, that is called near miss. But any incident should be reported, and it is very essential to report incident, because with the reporting, with the data, we got experience, and we can improve the things, and we can improve the overall health and safety standard of any laboratory. And historically, you can see, and these are known as pyramid structure of incident reporting over the time. In 1931, Henrik model shows like with 300 close call, there is one fatality. 1969, Bart Junior model shows with every 600 near misses, there is one fatality. And in 2003, ConocoPhillips model shows almost 300,000 risk behavior, there is only one fatality. So over the time, we got more and more experience by getting more and more incident report, and we are able to improve our overall health and safety standard and mitigate the highest level of risk. And this is the procedure, very easy procedure we used at our chemistry department. There is a QR code. You can scan this QR code with your smartphone, and you can report your incident immediately. So I will finish my talk with ergonomics. It comes with two Greek words. Ergon means work, and nomos means natural law. So ergonomics means the natural law of work. So over the times during the evolution, we know how to work properly. What should be the proper posture of our body. So we cannot compromise this posture by doing some work like crazily working on the computer or something like that. We cannot compromise. That is not the natural law of work. So ergonomics says emphasis of natural posture, but not allowing for dynamic movement, and it also allows you for being dynamic all the day. So when you are at the workplace, there is a risk of injury, and there are several factors for on this risk of injury. First thing is obviously your posture, whether it is right or wrong, and your body type, whether you are strong enough. Like for example, your lower body is not strong enough, so you are and you are working all the day, so there is a chance of injury in your lower body or your back. Then also it depends upon how long you are working in the lab, how often you are working how often you are doing a particular procedure, and how much you are doing with a wrong posture. So everything is associated with your injury. And the most common injury in a laboratory is, or any workplace, is back injury. So we believe a bent scientist cannot give you the best result. So if you have to force to be bent in your work, so it is better to like work on your posture. You can sit like this way, strengthen your straightening your back or your spine. If you are working on a bench and you have an obstruction on the leg, better you find a proper solution so that you can sit properly and you have a space for your leg. If you are hanging your hand in the air for a while in a few minutes, it can give you injury to your arm or your shoulder. So it is better to have a support on your arm. And the most common mistake we all do, whether it is a workplace or at home, is heavy lifting. So generally we lift heavy weight in a wrong posture. Always you need to bend your knee while you are lifting any heavy weight. So, and yes, of course, when you are in an advanced chemistry lab, you need to spend some time on your computer sitting. So sitting on a computer, you need to follow your right posture of sitting. A wrong posture can give you different kinds of injuries. And if you are in this state, like completely exhausted, so probably ergonomic is not your problem. You need to find out your proper work-life balance. So anyway, there are proper way to sit on the computer. I'm not going very detailed. So your eye level should be proper, your back level should be proper. You should have a arm rest, wrist rest. Your knee position should be proper. You should have support on the floor. So you need to follow all this like all these parameters when you are sitting. So in conclusion, laboratory safety is not a rocket science. It is very simple. All you have to do is understanding the hazard, following the proper procedure, and staying vigilant. And it is also important, like not only about your safety, you have to take care of your surrounding as well. And of course, safety is not a one-time checklist. It is a continuous habit to build a culture of health and safety. And building a culture of health and safety is not an individual job. It is a job of a team. So at our H3D chemistry, we have a group of C reps. They are quite efficient. For our 3 chemistry labs, we have 6 C reps or health and safety representatives. They are very energetic and very effective to ensure our health and safety standard. And I'm very thankful to all of them. Not only that, I would also like to thank all of our previous H3D C reps, because everybody is responsible to build a health and safety culture and making the standard of health and safety. So as H3D grows scientifically, our health and safety standard also grows, and scientific health and safety standard also grow over the time. And now we can proudly say that we have a global level, advanced level of health and safety standard. And we continuously work on that to improve that one. And we have great support from Occupational Health, Safety and Environment Unit from the chemistry department. Monique and Sophie, 2 officers, are always supportive to us and always give great suggestions. to improve our health and safety standard. This OHSC unit is a part of University of Cape Town OHSC, which get directives from Ministry of Labour from South Africa government. So lastly, I would like to share some important links which I feel quite important if you are interested in health and safety or want to improve your health and safety standard of your laboratories. So first link is our OHSC unit, chemistry departmental OHSC unit website, which is very comprehensive website, and you can find most of the stuff I discussed here. This paper in the second link is very important, very interesting paper. You can go through it. I'm not going through all the links, but I would like to highlight the last link, which is Laboratory Safety Guidance by Occupational Safety Health Act by US government. You can get the PDF from this website, which is very comprehensive document and which is good to have in your file. And yeah, you are welcome to reach to me anytime at any point of time. If you want to interact with me regarding any issues of health and safety standard or anything, you are welcome to reach out. And lastly, I would like to thank all of you for your kind attention, and please stay safe, stay healthy, and stay happy. Thank you. Any question, any comment? I'm happy to take.
Thank you so much, Sauvik. It's going to take me a minute just to open their microphones.
Yes.
And in the interim, what I'm curious about is how much time would you be able to share? How much time does it take to onboard somebody? So if a new scientist comes to the lab, how much time does one dedicate to that, at least in your experience?
Yeah, so that is a very good question, and we have a practice of that, like in part of onboarding process at H3D, and not only H3D, in chemistry department as well. We have a first, we need to go through, means any new person, whether is a postdoc student or an employee, needs to go through health and safety quiz first through the department. After going through all these online courses, which takes around, I guess, one and a half hour, and then after passing the questionnaire or the quiz, it comes to us, means the C-reps, and we go through an induction process in the laboratories, physical induction in the laboratories, and explaining all the health and safety stuffs. So it also takes around an hour or so for this induction process, one-to-one induction process. But it is quite overwhelming process, and for a newcomer, it is quite overwhelming to have all the documents. So I believe we can give the basic ideas before going in the lab, but it is a continuous process to learning the health and safety standard of a laboratory. Yeah. I guess I answered your question.
Yes, yeah, that's fantastic. Thank you. And yeah, I'm sure you do sort of regular updates and things like that. Yeah, so important to remember these procedures to make sure that we're actually managing to do the work that we, as you said about the posture alignment, I noticed myself sitting up in my chair and like, oh yes, I forgot about that. Yeah. Any questions from the group? Feel free to raise your hand or to pop them in the chat. I do have some shareable slides, which I'm happy to email to you afterwards if you reach out to me. I'll just give them a minute.
Let me stop sharing by the time so that I can see the audience.
Do you have any sense, Sauvik, of what's going to come in the future? I mean, is AI going to help us at all in kind of monitoring our labs, or being, what do you have any sense of what technology might come? Automations and things like that?
So definitely, like automation, basically lowered down the human errors, right? So we already have an automated purification system. So where we don't need to pack, we have the pre-packed columns for purification. We don't need to pack the columns with the silica. So we already mitigate some of the health hazard using the silica, like which is very fine particles. And over the time, if you inhale silica, you can, yeah, I have already mentioned, you can be exposed to silicosis. So this is one example. But yeah, so over the time, I think machine learning is going to help to improve the health and safety standard. But definitely, like human will be there, right? And our sense of or our culture of health and safety, that is always important. And that basic knowledge and that responsibility is always will be there.
And I liked what you emphasized as well, that, you know, it's a growing craft, as it were. So
Yeah.
the people who come before you, they start to build the foundations, and
Yeah.
you add to it and uphold the regulations and the rules, and you kind of build towards global standard, which H3D
Yes.
has achieved, which is incredible, you know. And kudos to you and your team and the people who came before you to, you know, for doing that for the lab work. And then also just the point that it doesn't make you a bad scientist to make those mistakes, right? Or to have an incident. And not disclosing that incident is actually not good at giving everyone the information they need to build the system that's actually going to work. So people have to come forward.
Yeah, that is a very important point. Like people don't need to be shy about making a mistakes. Like we all are human, and making mistakes can give you all the experience, like what to mitigate. For example, the face shield, what I mentioned, I myself had that experience. Like I was handling POCl3 and I didn't quench it properly. And when I tried to dump it to the waste, it comes back to me. Luckily, I was not damaged. That means that time it was just after COVID time. I have a face mask and mask and something like that. It saved my face. But from that incident, we experienced that it can happen to anyone, right? So we must report that incident. And not only that, we implemented the face shield to every lab, of every STD lab. So if somebody is forcing that there is a chance of this kind of spillage, if you are using a large scale of POCl3, something like that, if you are working up, if you are handling, I know you are handling properly, but still there could be some mistake. So not mistake, something can happen unknowingly. So yeah, face shield can save you in that case. So this is a case, this is a real case that I mentioned, which happened to me, and that's the way we improve our standard.
Right, exactly. Okay, well, it seems everybody's satisfied with that, and we're allowed to let you go, Sauvik. So thank you so much. It just leaves me to thank all our participants for attending week upon week. We're so happy to have you, and it really gives fuel to this webinar series that we're doing. Sauvik, thank you so much for your presentation and for reminding us all about these important rules and regulations. Okay, everybody, I want to remind you there's an opportunity to give feedback. I've put it in the chat. I saw there was one request for a similar presentation for a biology lab. If you have those kinds of suggestions, please pop them in the feedback form. Thanks so much, everyone. See you next time.
Thank you. Bye.
Bye.